Hi guys, in the last video we finished our chapter triangles. So let's start the new chapter, but before we start the new chapter, let's look at a couple of questions from the same chapter, triangles, where we'll try and prove some congruency, and this will help us to get into the new chapter. So let's look at this question. It says in triangle ABC, D is the midpoint of AB, which means AD and BD are equal, and E is the midpoint of AC. AE and CE are equal, which I have marked. We need to prove that DE is parallel to BC. That's part 1. And we need to prove that DE is equal to half BC. So to do this, I am saying let's construct a line CF parallel to AB. So I am constructing a line CF parallel to AB, and I am extending line DE to meet this parallel line at point F. So let's write this down. I am constructing line DE parallel to constructing a line CF parallel to AB, and I'm extending DE. So let's start writing this down. Construct CF parallel to AB. Perfect. And number 2, extend DE to join, or not to join, to meet. Not to join, to meet CF at F. Now that we've done this, let's look at triangle ADE and CEF. This angle and this angle is equal. Why? Vertically opposite. AE and CE is equal, already given, and angle A here and angle C here are equal because these are alternate angles. So now we will be able to prove that these two triangles are congruent. So let's start writing this down. So in triangle ADE and triangle CFE, what do we know? Number 3 would be angle BAE is equal to angle FCE. This is because alternate angles are equal. So we've got one part. Let's look at the second part, which is AE is equal to CE, since E is midpoint of AC, right? And then the last part is angle AED is equal to angle CEF. Why? Vertically opposite angles are equal. So we've got these 3 points. Therefore, by ASA test, that's angle side angle test, triangle ADE is congruent to triangle CFE. So that's my number 6. Now what does this help me do? Let's see if it helps us out. Next, that will mean let's apply CPCTC, which means DE will be equal to FE. This is CPCTC. So DE and FE are equal, which means this and this part are equal. And number 8 would be AD is equal to CF. This is also CPCTC. So if AD is a single line, CF is also a single line. So yeah, that's about it. So let's look at what else do we get in quadrilateral BCFD. What do we have? Number 9, BD is equal to AD is equal to CF. Why? Since D is midpoint of AB and AB, and from where do we say AD is equal to CF? From 8. So since AD is equal to CF and BD is equal to AD, therefore BD, AD and CF are equal. And number 10, BD is parallel to CF. This is by construction. We've constructed it in that manner. Therefore, quadrilateral BCFD is a parallelogram, since one pair of opposite sides is equal and parallel. So since one pair is equal and parallel, it will have to be a parallelogram. So now we know that BCFD is a parallelogram. Now, how does it help us in proving what we are trying to do? So if BCFD is a parallelogram, which means DF and BC are parallel. Perfect. So number one, therefore DF parallel to BC. Opposite sides of parallelogram BCFD. So these are opposite sides of parallelogram. DF is parallel to BC, which gives us number 12. Therefore, DE is parallel to BC. This is what they wanted us to prove. Correct? So hence proved. Why is DE? Since DE is part of DF. Perfect. So we've got DE is parallel to BC. My first part is done. Let's look at DE is equal to half BC. So let's look at number 13, which is DF is equal to BC. Why? Opposite sides of parallelogram BCFD. So opposite sides are equal in a parallelogram. Therefore, DF and BC are equal. So how much? What is the value? How can I break up DF? I can write DF as DE plus EF is equal to BC, which I can write as DE plus DE is equal to BC. Why EF and DE are equal? We have proved them in point number 7. DE and EF are equal. Since EF is equal to DE from number 7. We've already done that. So this was my number 15. Number 16 gives me 2 times DE is equal to BC, which means DE is equal to half BC. Is this what they wanted me to prove? Yes, DE is equal to half BC. So hence proved. So let's look at what we did in this. What we did was, if we had a triangle in which there were 2 midpoints, this midpoint and this midpoint, what we realized that the line joining the midpoint is parallel to the third side and is half of it. This is what we learned from this question. Let's look at the next question. The next question that we do is, in triangle ABC, D is midpoint of AB. So AD and BD are equal. DE is already given parallel to BC. So one midpoint is given and one parallel side is given. We need to prove that AE is the midpoint of AC, which means what we have to prove is AE is equal to CE. So let's see how we can go ahead and solve this question. So again, let's construct a CF parallel to AB, and let's join DE with CF. So let's write this down. We've constructed CF parallel to AB. Number 1, construct CF parallel to AB, and number 2, extend DE to meet CF at point F. Perfect. Now we know that in this BCFD, DE is parallel to BC and BD is parallel to FC, which means that BCFD is a parallelogram. Now let's write this in quadrilateral BCFD. Number 3, DF is parallel to BC. This is given. And number 4 would be BD is parallel to CF. This is by construction. So we've done this construction, which means these two sides are parallel, which means if both pair of opposite sides are parallel, then what does it make this figure? Yes, it becomes a parallelogram, since both pair of opposite sides are parallel. Therefore, BCFD is a parallelogram. So this is my number 5. So if BCFD is a parallelogram, it means that CF and BD are equal. It means that DF and BC are equal. Let's write this down. BD is equal to CF, and number 7 would be DF is equal to BC. Let's write this. Opposite sides of a parallelogram are equal. Number 8 is AD is equal to BD. Why? This is given. So combining 6 and 8, what do I get? That AD, BD and CF are all equal. I get AD is equal to BD is equal to CF. That's my number 9. So I've already put this single line here, single line here. Let's see if now I can try and prove these two triangles congruent. I have this angle and this angle equal. Why? Because these are vertically opposite angles. I know that this angle and this angle are equal. Why? Because these are alternate angles, and I know angle D and angle F are equal, which means why? Because these are alternate angles. So angle side angle, angle side angle. Perfect. So then I will be able to prove these two triangles congruent. So let's write this down. In triangle ADE and triangle CFE, what do we know? Number 10 would be angle DAE is equal to angle FCE, right? Number 11 would be angle ADE is equal to angle CFE. Number 12, angle AED is equal to angle CEF. And then the last thing is DE is equal to FE. Let's write the reasons. So let's write the reasons now. This would be, the first two are alternate angles, angle A and angle D. Yes, these are alternate angles, are equal. This is vertically opposite angle, and this is from DE and FE. Where did we get this equal? Not DE is equal to FE. We got AD is equal to CF. My mistake. This is not DE is equal to FE. My mistake. This is not. Number 13 is AD is equal to CF. This is from number 9. So we've got, let's mark this what I have said. I have said that this angle and this angle is equal. I have said this side and this side is equal. I have said this angle and this angle is equal. So what does it make? It makes it angle side angle. So let's write this down. Therefore, by angle side angle test, in fact, for doing this, I didn't even need to prove angle E equal. So in fact, I can remove this as well because this is not required. All I'm doing this is angle side angle. Had I used angle side, I needed this one. Otherwise, this is fine. What I get is triangle ADE is congruent to triangle CFE. This is my number 14. So how does this help me? It says that number 15 would be AE is equal to CE. Is this what we wanted to prove? Yes, this is CP, CT, C. Now we've got AE and CE are equal. So let's see, what did we learn from this? We said that in case we are joining the midpoint of a triangle with the other side and this line joining it is parallel to the third side, then the point on the other side will be midpoint of the third side. So this is what we get from here. So let's look at a question. Before we look at this question, let's say this chapter is called Midpoint Theorem and its converse. Now converse means the reverse of it. So let's look at midpoint theorem. Midpoint theorem says that if you have a triangle and in the triangle you join any two midpoints of two sides. So if I join the midpoints of these two sides, this line will be parallel to the third side and will be half of it. So in this case, A, B, C and D and E are midpoints. So if D and E are midpoint, then DE is parallel to BC and DE is equal to half BC. This is our midpoint theorem. And then what is converse of it? The converse says that if one is midpoint and the line is parallel, then this will have to be the midpoint. There are three factors, two midpoints. So those are the two given factors. The third factor that we figure out is it is parallel and it is half the third side. In the converse, it will be one midpoint given, one parallel side given, which means the other side will also be midpoint. The other point will be midpoint. Let's look at some questions. Maybe life will become simpler and it will be easier to understand. So let's look at question number 1 of our exercise. Question number 1 says, in triangle ABC, M is midpoint of AB. Like I said, you will get a lot of questions where the diagrams will not be given. So we, in our second exercise of triangles, we try to learn the skill of drawing drawing diagrams. So in triangle ABC, M is the midpoint of AB. So let's say this is M. It is the midpoint, which is AM and BM are equal. And line through M and parallel to BC. So there is a line which is going from M and it is parallel to BC, cuts AC at N. So this is parallel to BC. In fact, this looks like the second question that we did right now. One midpoint is given and the line is parallel to the third side, which means N will have to be the midpoint of AC. Will have to be. We'll write all that down, but we're just trying to understand what does it mean. So we've cut AC at N, which means find lengths of AN and MN if BC is equal to 7 centimeter and AC is 5 centimeter. So let's write this down. In triangle ABC, number 1, M is midpoint of AB. Number 2, MN is parallel to BC. Therefore, using converse of midpoint theorem. Why converse? In midpoint theorem, two midpoints are given. In converse, one midpoint and one parallel side is given. So using converse midpoint theorem, we get is MN is equal to half BC. We will not have to prove this every time. We can take this as given, as in this case this is converse midpoint theorem. So MN is equal to half BC. Now BC is given as 7 centimeter. Therefore MN is equal to half into 7 centimeter. Therefore MN is equal to 3.5 centimeter. Done. We've got the value of MN. And we need to find length of AN. So now we know, so using converse midpoint theorem, Mn is equal to half BC, and we also know that N is midpoint of AC. Since not since, we already said using converse midpoint theorem. Correct? So what we get is AN is equal to NC, since N is midpoint of AC, and which is equal to half of AC. So which means AN is equal to NC is equal to half into 5 centimeter, which therefore AN is equal to 2.5 centimeter. These are the two things that we wanted to get. So let's look at this again. One was given as midpoint and this was given as a line parallel to the third side. If such a thing is given, then the point on the other side will be the midpoint and Mn will be the half of the third side. Perfect. Let's look at the next question. The next question that we do is question number 2. So let's look at question number 2. Question number 2 says that prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. So there is a rectangle given. We need to prove that a figure obtained by joining the midpoints of these four sides will be a rhombus. So let's draw the rough diagram. This is first, this is another one, this is the third one, and this is the fourth one. Perfect. Let's give this some names. So this is A, B, C, and D, and this is E, F, G, and H. What is given is this is midpoint, which means these two sides will be equal. What is also given is this is also the midpoint, but since BC is equal to AD, which means the half of BC will be equal to half of AD. Perfect. Similarly, G is midpoint here and E is midpoint here. So now we've got the basic question correct. We've got the diagram correct. What we need to prove that EFGH is a rhombus. So how can we prove that EFGH is a rhombus? So EFGH is a rhombus. Now what property of rhombus do we know? We know the property of a rhombus is that all four sides are equal. Perfect. And I also know that I am in this chapter which is called Midpoint Theorem, which requires triangles. So as soon as you look at any two midpoints, you should, in your head, you should start saying, where is the triangle? Where is the triangle, so that I can get these two midpoints to be of one triangle, so that I can prove it to be parallel to the third side and equal to half the third side. That should be the first thing that should be going in your mind. So to make some triangle, I think we can join AC and we can join BD. So if I join AC and BD, I will get to see some triangles. Do I see triangle ADC where these two are midpoints? Perfect. And I saw triangle ABC where these two are midpoints, and then I triangle BCD where G and F are midpoints, and I see triangle ABD where H and E are midpoints. Perfect. So let's start writing what we already know. Number one, AB is equal to CD, already know. Number two, AD is equal to BC. Since ABCD is a rectangle. So that's our reason. Next, AH is equal to DH. Number 4 is equal to half of AD. Similarly, BF is equal to CF is equal to half of BC. Number 5 would be AE is equal to DE is equal to half of AB. Number 6, DG is equal to CG is equal to half of CD. I'm just writing the information that is known to us, and then this will help us move on from here. So now that we've got all of this, the reason for all of this is given, right? So all of this is given. So if I combine 1, which is AB and CD are equal, and 5 and 6, where we talk about half AB and half CD, what I get is AH is equal to DH, AB and CD. So AB and CD is AH is equal to DH. So not 1 and 5 and 6, the number I've written wrong. This is about, if I'm talking about AH and DH, then we are referring to the side AD and BC. So AD and BC is being referred to in number 2, and AD and BC is being referred to in 3 and 4. So what I guess is AH is equal to DH is equal to BF is equal to CF. And if I combine 1, 5 and 6, I get number 8, which is 1 is AB and CD. So I get AE is equal to BE is equal to DG is equal to CG. So these 4 parts are also equal. Now let's look at some triangles. So in triangle ADC, number 9, H and G are midpoints. So now that we've got two midpoints, so we are looking at this triangle for your reference, ABC. So we are looking at this triangle. These two are midpoints. So which means HG will be parallel to AC and it will be half of AC. So let's start writing using midpoint theorem. So from now on, I will be writing midpoint theorem as MPT. You should not be in your exam writing it as MPT. You should always write it as midpoint theorem. But for our class sake, we will be writing it as MPT. In an exam, you will definitely write it as midpoint theorem. So what I get is HG is parallel to AC, and what I also get is HG is equal to half AC. Perfect. Let's look at the next one. So now we look at the other triangle, which is in triangle ABC. So let's look at this triangle ABC, which is this triangle. Right? So now here E and F are midpoint. So let's see what does this give us. So number 12 will be E and F are midpoint. Therefore, using midpoint theorem, what do I get? EF is parallel to AC and EF is equal to half AC. Done. So what I have got is that these two sides EF and HG are both parallel to AC and they both are half of AC. So let's show this as parallel. This is parallel to this and this is parallel to this. So I think I've got at least HG and FE parallel, and I've also got HG and EF equal. Let's write this now. So from 10 and 13, I get number 15, which is HG parallel to AC parallel to FE. So HG and FE are parallel, which we've already done. And from 11 and 14, let's see, what do I get? What I get is HG is equal to half AC is equal to EF. So I have got HG and EF as equal. So I have proven one pair of opposite sides is equal and parallel, which means EFGH is definitely a parallelogram, but we don't need to prove it as a parallelogram. We need to prove it as rhombus. So let's try and do it for the other one diagrams as well. So let's look at the next triangle. So the next triangle that I'll refer to would be triangle BCD. So let's look at triangle BCD. So in triangle BCD, number 17 would be G and F are midpoints now. So G and F are midpoints. So using midpoint theorem, let's see what do I get. Number 18 would be GF is parallel to DB, and number 19 would be GF is equal to half DB. Perfect. So I've got one more pair of the rhombus that I need to prove is parallel to diagonal DB and is half of DB. So that brings me to the last triangle that we will look at, which is this triangle ABD. So now let's write this down. In triangle ABD, are there any midpoints? Yes, H and E are midpoints. So H and E are midpoints. Therefore, using midpoint theorem, what do I get? Number 20 would be HE is parallel to BD, and number 21 would be HE is equal to half BD. Perfect. So now I know that HE is parallel to BD. So let's represent this visually. HE is parallel to BD and BD is parallel to GF, which means GF and HE are also parallel and they are all equal to, both of them are equal to half of BD. So let's write this down. From 18 and 20, I get number 22 would be GF parallel to BD parallel to HE, and from 19 and 21, I get GF is equal to BD. GF is equal to half BD, sorry, not BD. GF is equal to half BD, which is also equal to HE. So now I know that GE and HE are also equal. So now both the pair of opposite sides are equal and parallel. All I need to prove is that these sides are equal. Now let's look at the number one. AC is equal to BD. This is the most important part. Why? Because diagonals of a rectangle are equal. So diagonals of a rectangle are equal, which means half of AC will be equal to half of BD. Right, half of AC, if AC is equal to BD, then half of this is equal to half of this. I've just divided both sides by 2, which means now I know that half BD here and half, where did I get this one here, half AC, all these are equal. So let's write this down. From 16 and 23, what do I get? I get is number 26, which is HG is equal to EF is equal to half AC, which is equal to half BD, which is equal to GF, which is equal to HE. Since all four sides are equal and opposite sides are parallel, therefore EFGH is a rhombus. Long question, took us a long time to solve, but the concept was simple. The first thing in this question would have been to identify these four triangles, and that's what I said. Like when you look at a right angle triangle, the first thing that comes to your mind is Pythagoras theorem. Similarly, starting from now on, whenever you look at a triangle and two midpoints, the first thing should come to your mind is midpoint theorem. So you look at midpoints in a triangle, think of midpoint theorem. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye-bye.